Alright, so the factor theorem says let f be a polynomial function, then x minus c is a factor of f of x if and only if f of c equals 0. Alright, so that's actually kind of two statements. If f of x has a factor of x minus c, then we know f of c equals 0. And then the reverse would be true. If f of c equals 0, then x minus c is a factor. So we'll kind of look at both of those things in this example we have. And the question in this example is x minus 1 a factor of this polynomial here, f of x? Alright, so using the remainder theorem, I could plug in 1, right? It's x minus 1, so it says to kind of plug in 1. And if I got 0, then I know that it's a factor. Alright, so I'm actually going to do both things. I'm going to plug in that and know, and then I'm going to actually show how this would work in a factor box like we've kind of been doing. So I like the multiple strategies here. So this factor theorem is saying if it's a factor, then f of 1 will equal 0. Right? So we got to figure out if that's actually true. So I'm plugging in 1. By substituting every x is going to be replaced with 1. And I'm going to evaluate. This is going to save me tons of time in the future, right? Remember, don't plug in -1. It says x minus 1 is a factor. So then the root or the potential x-intercept would then be positive 1. Okay? So don't get that mixed up. Remember, the form is x minus c, and c then, if it's positive, then we're going to plug it in here. If it was already negative, then we would do the reverse. Okay. Let's evaluate. 1 cubed is 1, so that's just 2 times 1, which is 2. Minus 1 squared is 1. 2 times 1 is 2, minus 3. 2 minus 1 is 1, plus 2 is 3, minus 3 is 0. It is, in fact, a factor. It is in fact a factor, and this factor theorem helps us see that. It also, the remainder theorem also helps us, which is the last video where we plug in. Our remainder is 0. And if there's a 0 remainder, right? When we did the first example of 30 divided by 5, 30 divided by 5 is 6 with no remainder, meaning 6 is a factor, right? 5 is a factor too. So let's look at the factors then, because this is going to help us with our next step. Okay, if we know that x minus 1 is a factor of this, that means it can divide it. Okay, so let's try to do that with a factor box, and it's going to extend really nicely into our next example. In other words, you don't always have to use these factor boxes to check to see if it's a factor, but you might want to if you want to keep going. So what I'm going to do here is I'm going to be dividing 2x cubed minus x squared plus 2x minus 3 by x minus 1, because I know it's going to work out perfectly, and I'm not going to get a remainder. I know that because of this factor theorem and the remainder theorem. Okay? So 2x cubed, this is going to have to be 2x squared. Remember, 2x cubed was the first term I needed. That's 2x squared. 2x squared times -1 is negative 2x squared. How many x squared terms do I need? I need a negative x squared term. I've got -2 of them already, so I'm going to put a positive x squared term here. Okay, how do I get x squared? Well, this would have to be x as well. X times x is x squared. X times -1 is negative x. Okay, so I've taken care of that term. I've taken care of this term. I need the 2x term. I've got a negative x, so I need to get 3 x's here. Okay, that means this is going to have to be 3. 3 times x is 3x, certainly. 3 times -1 is -3. And look at that, it worked out really nicely. Every term is represented. So what that means is f of x is factored. It's in factored form would be x minus 1 times 2x squared plus x plus 3. Now this could be factored further, potentially. I'd have to investigate that. But we really just rewrote f of x as the product of two other polynomials, which can be very helpful when breaking it down, because then I can find the other roots from that. And that's what we're going to do in this next video, where you're given a hint. But sometimes you'll be asked if something's a factor, and you can simply use this factor theorem to check it. And if you know it's a factor, then sometimes that can also help you by factoring the rest of it further down. Okay, so using the factor boxes and using all these wisely will help you. Check out the next video on how we would go further.